We want to show that the points A 4, 7, B 1, 5 and C 6, 4 are the vertices of an isosceles triangle. An isosceles triangle, remember, will have two lengths the same. So that is going to be our approach here. We need to look at the lengths of the sides of this triangle and show that two of them are the same. It's often useful to draw a sketch to see exactly what you're dealing with. It doesn't need to be accurate, it just gives you a picture. So if we draw a pair of axes and draw on the point B here, which is at 1, 5, and the point A, which is at 4, 7, and the point C, which is at 6, 4. We can now draw the triangle ABC, and if we call this distance DAB, this distance DAC, and this distance DBC, then we'll want to calculate those three distances in order to see if two of them are the same. The distance formula is D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. In practice, it might be better to think of this as the difference between the two x-coordinates squared plus the difference between the two y-coordinates squared. If we start by looking at the distance between A and B, which we've called DAB, we have the point B, which is 1, 5, and the point A, which is 4, 7. The difference between the x-coordinates, 1 minus 4 squared, add the difference between the two y-coordinates, and the y-coordinate of B is 5 and of A is 7, so 5 minus 7 squared. One take away 4 is minus 3 squared is 9. 5 minus 7 is minus 2, and minus 2 squared is 4. So this is the square root of 13. Now calculating DAC, the distance between A and C, we know that the x-coordinate of A is 4 and of C is 6. So we're going to do the difference in the x-coordinates, 4 minus 6 squared, add the difference in the y-coordinates, so that's 7 and 4 for C, so 7 minus 4 squared. So this is the square root of minus 2 squared, which is 4, add 3 squared, which is 9, so this is the square root of 13. Clearly DAC and DAB are equal, so two of the sides are equal, but we may go ahead to calculate the third side just in case the triangle is actually equilateral. So if we now consider DBC, we have 1 and 6 as the x-coordinates. The difference between the x-coordinates then is 1 minus 6 squared. And for the y-coordinates we have 5 and 4, so 5 minus 4 squared. Minus 5 squared is 25, and 1 squared is 1, so this is root 26, so this length is not equal. These two are, so we have an isosceles triangle since the distance from A to B is equal to the distance from A to C, making two of the sides the same length.